Welcome to Space Oddities and this episode of An Astronomical Life. The life we are looking at today is Dame Susan Jocelyn Bell Burnell. Early life and education. Susan Jocelyn Bell was born the 15th of July 1943 in Lurgan, Northern Ireland. Her parents were George and M. Alison Bell. Her father was an architect who helped design the Armagh Planetarium. Jocelyn's early interest in astronomy. Her father's involvement in the planetarium sparked her interest in astronomy. He provided books on the subject. One author in particular inspired Jocelyn's interest in astronomy, Fred Hoyle. He would later, on more than one occasion, play small parts in Jocelyn's future. Jocelyn attended Lurgan College, where she faced gender barriers, initially not allowed to study science. After failing her 11 plus, Jocelyn's parents sent her to the Mount School, a Quaker boarding school in York where she excelled in physics. There she was favourably impressed by her physics teacher, Mr. Tillott, and stated, "You do not have to learn lots and lots of facts. You just learn a few key things, and then you can apply and build and develop from those." He was a really good teacher and showed me actually how easy physics was. After York, Jocelyn moved to the University of Glasgow, where she earned a Bachelor of Science degree in physics in 1965. Next for Jocelyn was the University of Cambridge, where she pursued a PhD in radio astronomy under the supervision of Anthony Hewish. Discovery of pulsars. Jocelyn focused on constructing and utilizing a large radio telescope, the Interplanetary Scintillation Array just outside Cambridge, to study quasars. The remains of the Interplanetary Scintillation Array just outside Cambridge still exist today. Data collected by the Interplanetary Scintillation Array was recorded on a tracing machine similar to the image on the left. Every day Jocelyn collected reams of data, come rain or shine, and returned to her student accommodation where she would then analyze the data. Observations. Jocelyn detected a series of unexpected radio pulses on the 28th of November 1967. Jocelyn described this as a little bit of scruff in the trace. Jocelyn realized she had seen this little bit of scruff before. Going back through the data, she found a second signal on the 6th of August 1967. The signal was repeating. Jocelyn reported her findings to her mentor, James Hewish, who in turn notified his superior, Martin Ryle. Initial skepticism. The pulses were nicknamed LGM for Little Green Men, due to the possibility of extraterrestrial origins. LGM as a nickname would later prove to be a problem. Before the nature of the signal was determined, the researchers, Burnell and her PhD supervisor, Anthony Hewish, considered the possibility of extraterrestrial life. He said, "We did not really believe that we had picked up signals from another civilization, but obviously the idea had crossed our minds, and we had no proof that it was an entirely natural radio emission. It's an interesting problem. If one thinks one may have detected life elsewhere in the universe, how does one announce the results responsibly? Who does one tell first?" The signal was confirmed. They had found and identified a repeating signal which led to the conclusion of a new type of celestial object. But what was this object? Astrophysicists, including Fred Hoyle and Thomas Gould, posited that the new discovery were from the remains of a collapsed star called a neutron star. The signal were confirmed to be from a rapidly rotating neutron star, later termed a pulsar. Jocelyn Bell co-authored a paper in 1968 detailing the discovery with her supervisor Anthony Hewish and other colleagues. A public announcement was made of the discovery in February 1968. Jocelyn later related how the media was covering the discovery of pulsars, with the interviews taking a standard discussing format. Hewish would be asked questions on astrophysics, and she would be the human interest part, asked about her vital statistics, how many boyfriends she had, what colour is her hair, and asked to undo some buttons for the photographs. Recognition and Nobel Controversy. The impact. The discovery of pulsars was a groundbreaking announcement in astrophysics. Nobel Prize. In 1974, Anthony Hewish and Martin Ryle were awarded the Nobel Prize in Physics. Burnell was not included, leading to widespread debate and criticism regarding the exclusion of her critical contributions. Some even today refer to 1974 as the Nobel Prize in Physics. At the time, one of the loudest voices in support of Jocelyn Bell Burnell was fellow astronomer Fred Hoyle, who severely criticized the Nobel Committee for Bell's omission. It is thought this episode contributed to Hoyle being overlooked for a Nobel Prize in 1983. On this episode of the Nobel Prize controversy, Jocelyn later reflected. She said, first, demarcation disputes between supervisor and student are always difficult, probably impossible to resolve. Secondly, it is the supervisor who has the final responsibility for the success or failure of the project. We hear of cases where a supervisor blames his student for a failure, but we know that it is largely the fault of the supervisor. It seems only fair to me that he should benefit from the successes too. Thirdly, I believe it would demean the Nobel Prizes if they were awarded to research students, except in very exceptional circumstances, and I do not believe this is one of them. Finally, I am not myself upset about it. After all, I'm in good company, am I not? So, what is a pulsar? Definition. A pulsar is a highly magnetized rotating neutron star that emits beams of electromagnetic radiation. Formation. Originates from the remnants of a supernova explosion. Rotation. Spins rapidly with periods ranging from milliseconds to a few seconds. Emissions. Emits beams of radio waves, X-rays or gamma rays. Lighthouse effect. The beams sweep across space and, if aligned with Earth, are detected as pulsating signals. Magnetic field. Extremely strong, influencing the pulsar's emission mechanisms. Significance. Used in astrophysics to study extreme states of matter, gravitational waves, and space-time. Acknowledgements. Despite the controversy, Jocelyn received numerous accolades, including the Albert A. Michelson Medal, the J. Robert Oppenheimer Memorial Prize, and the Herschel Medal. In 2018, she was awarded the Special Breakthrough Prize in Fundamental Physics. Career and contributions. Research positions. Jocelyn worked at the University of Southampton, University College London, and the Royal Observatory, Edinburgh. Focused on gamma-ray astronomy, infrared astronomy, and the emission of X-rays from neutron stars. Academic roles. Held various teaching positions at prestigious institutions. Appointed as Professor of Physics at the Open University. Became a visiting professor at Oxford University and later the Chancellor of the University of Dundee. Leadership roles. Jocelyn became President of the Royal Astronomical Society, the President of the Institute of Physics, and the President of the Royal Society of Edinburgh. Advocacy and legacy. Promotion of women in science. Jocelyn actively campaigns for greater inclusion and support for women in STEM fields. Personal experiences. Frequently shared her own experiences with gender discrimination in her career. Philanthropy. Donated her Breakthrough Prize money to fund scholarships for women, underrepresented minorities, and refugees studying physics. Continued engagement. Jocelyn remains an active figure in the scientific community, participating in lectures, conferences, and public outreach. Advocates for education and the public understanding of science. Honours. Numerous honorary degrees and fellowships from leading universities and scientific societies. Continues to be a role model and an inspiration for aspiring scientists, particularly women and minorities in physics and astronomy. Selected publications and works. Pulsars and neutron stars. Jocelyn authored and co-authored several important papers on the nature and properties of pulsars. Books and articles. Contributed to various scientific publications and books, sharing insights on her discoveries and the broader field of astrophysics. Educational contributions. Involved in the development and educational resources and curriculum for teaching physics and astronomy. These are just two of the titles that Jocelyn was involved with. Influence on astronomy and physics. Pioneering work. Her discovery of pulsars has made a profound and lasting impact on the field of astrophysics. Inspirational figure. Recognized as a trailblazer for women in science and an advocate for diversity and inclusion in the scientific community. Enduring legacy. Jocelyn Bell Burnell's life and work continue to inspire and influence the next generation of scientists, contributing to the advancements in our understanding of the universe. Key personal qualities. Resilience. Jocelyn overcame significant barriers and challenges in her career, maintaining a commitment to her scientific pursuits. Humanity. Consistently acknowledged the collaborative nature of scientific research and the contributions of her colleagues. Mentorship. Played a significant role in mentoring young scientists and fostering an inclusive academic environment.